Okay, go ahead.
Good morning, everyone. My name is Lin Zhou, and my major is materials engineering, and my advisor is Dr. Tizen Li. Today I will talk about the proprietary view of the nanoporous mechanism. First, I will give a background about the hydrogen energy. Then I will tell the materials to store the hydrogen energy, especially, and I will control my mind on the proprietary ways, especially about the template method. And finally, I will give a brief summary. Our Earth have abundant water, so we can use the water to have enough hydrogen energy. And hydrogen energy they can react with oxygen to release the energy, and also the product is water, which is very convenient. And also the NASA has used hydrogen fuels to launch the space shuttles, because the hydrogen may hold more cubic energy than other fuels. And also for our future use, maybe we can use the hydrogen power instead of nowadays used the gas station or oil station for our future use. And this is a thunder. And for this hydrogen energy process, our research especially cares about the hydrogen storage, how this hydrogen can be stored. There can be easily or conveniently for people to use. Our research concentrates on hydrogen storage. So we try to store the hydrogen in the materials in the mechanism. So how these materials can store the hydrogen energy? Because they have a reaction with the hydrogen to a solid magnesium hydride. This is very safe for the hydrogen energy to be kept. And also, it's easy to be released just by heating, or you can just react with oxygen to release the energy. Why we choose the mechanism of the special materials? Because materials they can have a higher volumetric capacity, and also it's have higher gravimetric capacity. What's more important is that its abundance is around 2.5% of Earth's surface concentration, and also it's unlimited amounts in the seawater. And finally, there is no toxic. It's very it was very safe. So we choose mechanism as our proposed materials. And there are so many states about the mechanism. The bulk materials, they don't react with the hydrogen there. So we don't use the bulk materials. And if we use the light particle mechanism, it can combine with the hydrogen, but they have a disadvantage in safety, because we can't keep the light particle states there. There are also some materials about use the organic polymer to hold those light particle to let they have a safety state, but that's not all we research. We hope that we just fabricate materials that they have the light porous structure. So that's also very safety. If that's true, it's easy for us to hold the hydrogen energy just in this pure mechanism. This is the structure of nanoporous structure. This is the model And also our literature, they have some NADPOR structure like the honeycomb. This is the non-metal structure, NADPOR code. This is the structure pictured by the TEM. For the preparation ways, we especially use the template method. In this picture, we can that there are two respective synthesis routes for those metal porous materials. Metal porous materials actually is a kind of NADPOR materials, but they may have porous is a little larger. For those two ways, the first one is the soft template method. They just remove one materials and then they have the pores. Actually, these pores in a real experiment is not a round cross. It's just like it just a place, a space, not a round core. But it's also called metal pores or NADPOR. And then the B is about the hard template method, or also calling about the nano casting. Because it's just like the casting. We have the NADPOR structure. Then we filled those structure with the materials. Then remove those NADPOR structure to have this product with a NADPOR structure. So here I give example of the NADPOR structure carbon that had been fabricated by some researchers. They use the colloidal silica. Then they use the polymer films. Polymer films was real on the surface of the silica colloids. Then by carbonization, they carbonization filmed polymer will be on the surface of the silica colloids. Then remove this template. Actually, in this appearance, silica is the template. Silica is easy to remove, maybe by in HF acid. That's very easy. So we get the porous carbon in this experiment. And also the PXB tells that the process may have effects on the other person about the gas. So maybe we should choose a special process, not neither too big or not too small. Just a special process to have the higher gas medium holder. And then I will give a special about the NADPOR mechanism that we want to fabricate it. There's some hypothesis ways. The first use is by the set template. We want to we have the materials, the green reagents may have the mechanism in these materials. If we can remove the other materials, we just remain the NADPOR mechanism, the mechanism. Maybe we should get the NADPOR mechanism only, but this way is had problem that we can only get the product like that. It's harder to just get the pure mechanism that we wanted. So we don't use this way. And for the two states of the mechanism, the pure mechanism or the mechanism iron, if we use this mechanism iron, we can hold this the mechanism iron with template. Then by remove the template, we have two. Maybe we can have two products. One is the pure magnesium, and the other is the magnesium composite or combined. Because magnesium, magnesium it has higher reducibility, so it's harder to reduce the magnesium ion to the magnesium. So it's harder. Even though they have some ways like the microwave or the using the plasma to reduce the magnesium to the pure magnesium, but this is also maybe it's high cost. Then we want to just use the pure magnesium and template, and then the magnesium they don't react with this template. They keep their magnesium, pure magnesium state. Then we remove those templates to get the net pearl structure. This sort of roots is what I research now. Because we want to let this pure magnesium and template they combine very closely. Because if the magnesium and template they don't compare too closely, maybe we can just have the porous structure. Maybe the pores are so larger, not the narrow porous structure. We also have research about that when the pores they get to the ladder, it's better to store more hydrogen energy. So we want to have those narrow porous structure. And other ways to have this narrow porous structure is that we use a member. Usually maybe we can use the ethylene. This is very popular monomer. And also we can have the nanoparticle magnesium. The nanoparticle magnesium we can have some ways to fabricate it. They have so many researches do the work about the nanoparticle magnesium. So that's easy to get the nanoparticle magnesium. For the nano and the nanoparticle, we should polymerize those two to get a solid. Yeah, to get a solid. Also, to get a solidified products, we need to specially choose the monomers. The monomers, when they polymerize, they can have a solid state products. Then we can remove this polymer to sometimes, usually it's the irregular pairs. We can also improve our experiment to get the regular pairs, but network is really hard. Our network is just to find that to get the net pearl structure to have the irregular pairs. And for the remove ways, we have three remove ways. One is in evaporate, and then the second one is calcinate, and the third one is dissolve. Those ways they should be related to the materials we used. If we use some polymer that it needs to evaporate, maybe that is possible. And for the calcinate, calcinate is what we try to use now, because the calcinate it's some polymer like the PE it can deposit in around 200 temperature. So if we just control those experiments, we can we maybe can have the net pearl magnesium we need. And for the dissolve, now we do not use this. Now maybe we will use it later. Because in this way we should have the special organic solid. These solids, because the solid when the solid they dissolve in the organic solution, it can easily expand. It will maybe never change the structure we need. So we will not try to use this way. We will just try to use the second way in our experiment. Maybe in our future, our research can rely on the manner and the mechanism, how they are composition. Because we use different composition, we can have different products, and we need that the mechanism is the matrix of our product. When we remove this template, we will get the net porous mechanism that we need. So in this presentation, I tell the importance of the hydrogen energy. I also told the special materials, the mechanism to store the hydrogen energy. I also tell the advantage of net porous mechanism. And finally, I especially talk about the preparation process, especially the temporary to fabricate the net porous mechanism. So that's all. Thanks. That's the reference. Any questions?
Time for one question. I'll ask one. One problem that's common in a lot of hydrides is that the process of charging and discharging oftentimes leads to physical damage of the crystal structure due to usually volumetric expansion. So the powders break down and you lose a lot of the structure. Is that observed in this as well, or is that a problem with the magnesium?
In some papers, they tell that maybe in the net porous structure, maybe they release the hydrogen. They will keep their structure. Yeah, they will keep their structure. If that's because that's really good, because we can recycle. Yeah, we just our research actually do about the first part, fabricate net porous mechanism. Maybe in the second, maybe we'll do later. Yeah.